Wait, can you try?
Yes, I've got audio.
Can you try Skype from that to make sure we're able to send the sound?
Okay, so I need to get the presenter now.
Yep, audio works.
It works. It works.
Yeah.
It works.
Okay, give me 1 second so I can get the presentation up and then we'll be done. For me, yeah.
It's now time for Q&A.
I feel naar een Samsung Joyent.
We're good to go. Yeah.
Almost.
Hold on. Almost. You know if it's working.
Yeah, well, audio is dropping.
Het enige wat je af en toe leest is een quote van IDC, dat Windows 8 nu toch echt heel veel beter is. Daar blijft het mooi. Weet je, soms een beter uitziet.
So is it helpful if I stand here with the audio? I mean,
No.
it doesn't matter. It picks up anywhere in the room.
Yeah.
All right.
Okay, so we're good to go? Kind of, sort of?
Kind of, sort of.
Okay. So, good evening. Finally, I've lost track of time, but I think we are about 30 minutes late. Thanks for joining here in the room. Thanks everyone listening on the channel. This is my first time, so if I do something stupid on video, bear with me. I first want to introduce Max Bruning. I'm not sure if he's on camera or not. Our speaker for this evening. Since you're running late already, I really briefly want to introduce everyone here. And why I'm not on full screen? Things keep going wrong. That's okay. So thank you, Max, for being here. Thank you for flying in. We got you about 1 hour early for being that you came here today. Thanks, Deirdre, for organizing this. Thanks, Jeroen, for coping with all the stress and all that. Thanks, NLUG, for making all this possible. Thank you for being here this evening. We are going virtual, in case you didn't notice, and well, we are kind of still rehearsing, and hopefully it will be better next time. If you want to do Q&A, that's possible. The whole thing is being recorded and being put on YouTube, so you can watch again, and other people can watch. That means that there is a little rule that we need to do with the Q&A. If you go on Twitter and type your questions to @NOSIG.org, we will catch it. Max, in his flow, will open up room for questions. Then we can handle the questions that I will read from Twitter and that we'll catch from the room. So please don't be too interactive this time. Normally we like it to be interactive, but not this time. And it will be recorded that way, so people can afterwards also see the Q&A that we did. Okay?
Bigger. But this is correct.
Yeah.
But bigger.
Let's see if I can make this full screen. That would help. Full screen. Yeah. Okay, so for introductions, SmartOS is the subject at NOSIG.org is to Twitter, yeah. So SmartOS, everything SmartOS this evening. Part 1, introduction to Joyent and to SmartOS. Then Max will elaborate a lot on the modifications that Joyent made to the source, the Solaris source that we put out as build 151 at the time, making it into SmartOS. And then the last subject before the break will be how zones are used for cloud provisioning. So it's all about cloud this evening. Then after the break, and I think we should do a very short break this time, continue with part 2, the KVM implementation that has been put in SmartOS and that makes it unique compared to other Solarises out there. I hope you agree because we talked about
this is kind of what I'm doing.
Oh, good, fine. We have a mess with the slides, yeah. So who are we? Also for the recording, we are the Netherlands Open Solaris Interest Group. There's a little red box between Open and Solaris. That means there's a space. Yeah, so it's not Open Solaris as we used to have it. It's an open group about Solaris. So we love all kinds of Solarises. We love SmartOS already without knowing anything about it. We are the technical community of the Netherlands Unix User Group. who is also helping making things like this happen. Thanks for that. Then we have the roots, indeed, in what used to be the OpenSolaris without a space user group at Sun. So that's where the love started, and we continued after Sun was acquired by Oracle, and then we put in the space. So we are about all these Solarises. And the goal is simple: enjoy, share, and evangelize Solaris, which is what we're doing this evening. Any type of Solaris. We are on Twitter, we are on LinkedIn, we blog, we are all over the place. Hopefully everyone knows that, otherwise you can look it up in the recording. If you want to join us, join the members at NOSIG.org alias for any questions or any suggestions. If you want to join the core or talk to the core, the people kind of driving this group, join core at NOSIG.org, send messages there. Some links, joyent.com being the most important, and smartos.org, found that one. And with that, I leave it to our presenter for this evening, Max. Yeah, it's you.
Where did that phone come from?
Alright. Now we need to switch to your slides.
Arrow key show.
Oh, that works.
Great.
Okay, so yes, my name is Max Bruning, and I'm going to talk pretty much the entire time about stuff we've done in SmartOS, enhancements, additions, bug fixes, some functionality, improvements or additions. Very brief discussion of Joyent and SmartOS, very high level. Then I'm going to just dive into things that we've done. And this whole talk is going to be basically on these last four things. I should mention that I make an assumption after Bart. We talked about this for a bit, and the assumption is everyone in here already knows Solaris. If you don't, yeah, we can teach you courses on it, but I'm going to make an assumption that you're already up to speed. You know Solaris fairly well, so here's what we've done to it. Okay, so or Illumos, we call it SmartOS, and we use it for two products, something called the Smart Data Center, which is basically orchestration software allowing users to build their own public or private clouds. And this basically is software that sits on top of SmartOS, and it instruments things. So you can say, I need a new 1 gigabyte machine, and the Smart Data Center will pick a machine and instantiate a virtual machine on that particular physical hardware that was picked. The second thing we use Smart Data Center for is something called the Joyent Public Cloud. And I don't know if people saw this, but is there a way I can go really? I had this up here at the beginning, and I have to do this because otherwise people in Joyent are going to say, why do we send this guy to Amsterdam for 2 hours? So there's got to be a faster way.
Face down, maybe? Oh,
okay, so at any rate, the Joyent Public Cloud is, we've got data centers in a couple different places in the States. We have one in Amsterdam, in Europe. We've got some in Asia. And if you go to this website and sign up, I'm marketing. Am I doing sales work? So at any rate, we have an offer for the first 50 sign-ups, and it'll basically, if you sign up, it'll ask you for billing information, and if you just use this code, EU Joyer, you get a machine, I think it's for 1 or 3 months to play with.
Didn't work for me. Just tried it.
You just tried it and it...
You have to put in all your billing information. If it's free, then I'll try it.
no, I completely
I'm
understand.
Dutch, so-
I wouldn't be happy about putting my credit card. I didn't get that far. I started it and I said, no, I'm not entering a credit card. I just did that today. So you have to enter the credit card before you can...
Well, you can enter the coupon code, and once you press submit, it says, well, you're missing all of these fields.
Okay. Well,
It starts with the expiration date, which is invalid. If you just enter the coupon code.
I see. All right. So, Deirdre, if you're hearing this, if you can ask
Web development.
not sure, whoever it was that gave me the code. All right. So at any rate, the Joyent public cloud, and with this you can say, oh, I need 5 what we call smart machines, which are basically zoned instantiations on top of SmartOS. Or you can say, I need 5 smart machines and I want to get 3 Linux machines. So this is the basic idea. So the Joyent public cloud uses the instrumentation software, and this all sits on top of SmartOS. I am not going to spend any more time with either of these in this talk. So I'm just sticking to SmartOS because that's what you guys are here for, I think. So all of our machines, where a machine can be either what we call a smart machine again, which is just a normal zone in Solaris, or it can be a virtual machine, Linux, Windows, FreeBSD, whatever. And all these different machines run in their own zones. So this is what we use the software for. Okay, for those unfamiliar with this, okay, so do I need to go into history here? I had to put some graphics in this, and everyone knows history, right? We move on?
Yeah.
We're okay? And the people who are watching this, the 2 million, or was it? Yeah. We still have 2,020,000 people watching this from around the world. If it's not, if you need more information on the history, please ask on Twitter. Okay. Okay, so we use zones in SmartOS for provisioning machines, and we basically use them for the typical reasons: isolation from fault, resource control, so each zone can have its own set of resource controls. I'm going to talk about some of the resource controls that we've added and modified the way they work, and for privileges. Many of Joyent's services, also the services that make up SDC, also run in their own zones. So that's the instrumentation software. Okay, so now I'm just going to go into things that we've changed. All right. Yeah, I know. I think so. Okay. So RCAPD. RCAPD, the resource cap daemon. This is a single-threaded process that handles all zones on the system. So it doesn't really scale well when you've got hundreds of zones on the system. And the zone's memory cap is not a resource control. So you've got this separate mechanism for managing a zone's memory cap. Monitoring can only be done by RCAP stat. This is not a K-stat, in other words, it's just a completely separate mechanism. SmartOS, we have a thread in zone ADMD for memory capping. There's one per zone. So instead of one system-wide, which is what was being done, we've got one of these guys per zone. The cap itself, the memory cap, is implemented as a resource control. Statistics are maintained as K-stats. The RCAPD service is still there, but we've disabled it. It is still there because projects that are doing memory capping need it, and we're not we're not doing anything with projects in our product. So it's still there. We just don't have it turned on. We also can get per zone load averages. Okay, with this mechanism, and just a little more information. So here I am printing out the maximum physical memory, the memory cap for the zone 87B5, blah, blah, blah. Okay. So it's a resource control, an RCTL. And the current usage on this zone is 142 meg, and the cap is at 1 gig. Right? Pretty straightforward, I think. Okay, K-stats. So here I'm dumping out the K-stats for, again, this zone 87B55, and I should, it'll become obvious as we go through this. We use UUIDs for everything, as far as naming purposes are concerned. You can create aliases and names, but basically we use UUIDs. So I'm dumping out the zone memory cap statistic for the zone whose instance number is 895, and you'll see the physical cap is basically 1 gig. It's in bold, and resident set size, the RSS value is about 24, 25 meg, right? 256 meg, sorry, thank you. About 256 meg right now. There's another form of this which just gives you a less detail. And again, it shows you usage and value in the zone name. The other fields up here, a non-alloc fail, non-page in, exec page in, file system page in, etc. And N over, I guess I should mention. N over is the number of times you've gone over the cap. So the memory cap, I don't know if you're familiar with this, but the memory cap is something that can be exceeded. We can't constantly watch to make sure that you don't go over your cap. It's too expensive. So we have this daemon thread running in zone ADMD now. It used to be in RCAP, whatever it was, RCAP-D, thank you. So we have this thread running that periodically checks, are you over your cap? If you're over your cap, it will bump N over, and it will start paging out pages for that zone. All right.
I think you need to do as much desktop sharing as possible and not the live camera, because people can't see the slides when on live camera.
Okay.
That's what I'm trying to wave and point at you.
What? So people are seeing like here.
Yeah, but you just can't read the slides. It's too small.
Oh, the slides
it's like
are too
this.
small.
So then you do all the number talking and people can't see. So that's why I was trying to interrupt without you noticing.
I see.
To do as much, just show the slides.
You have a call.
I do. I don't know that lady. Who's that?
So is there a way to bring the camera in, other than physically pick it up?
No, but I can show the presentation.
Oh, that's fine. So you can.
I'm just trying to keep up with you.
Okay.
But if you point at something, then it's good that they see where they point at.
Okay. We move on.
Hope so.
Okay, so zone memstat is a command that basically we use as a replacement for RCAP stat. This shows some zones on the system that I happen to be running this on, and it shows the current memory use for each zone. It shows the cap for each zone. It shows the number of times the zone has gone over the cap, and the amount of pages that have been paged out. So we've got this one zone that went over the cap one time, and 67 meg got paged out for that zone. We actually use this So if you want a new smart machine, or new smart machine, and you need to determine how big should it be. So you're going to run some application. You're going to run I don't know, MySQL, MySQL. You're going to run Apache. Whatever you're going to run on the machine, you need to have some idea of how big to make the machine. So what you can do is come up with a guess as to how large to make it. Run the application. Run zone memstat, and yes, there's an option to give you just that particular zone. Or if you run in the zone, it'll only show you the current zone that you're in, and it'll tell you how far away you are. So we've had one customer who built these 32 gig machines, and it turned out that they only needed about 2.5 gig. It's okay, you can shrink it down. You're not using it, and here we can show it. All right. Or you can continue to pay for 32 gig. It's completely up to you. Okay, so some more changes related to this. So the residence set size calculation, RCAPD and PRStat used a system call called getVM usage. They still use this, but they use this to determine RSS, and for large processes, we're talking big database, for instance, from a company called Oracle, as an example. For a very large database, what can happen is getVM usage actually locks the process down as a lock and slash proc. It locks it down, and it causes everything to back up because of it. So, so it introduced noticeable latency as the process is stopped during the calculation of the size. Now, the good news about getVM usage is that it did not do things like count shared things more than once. So if you had if you're using libc, it's not going to count all the pages of libc you're using n times if you've got n applications. I should come over here, like this.
Yeah, that's fine.
But
That's fine.
Okay. I'm sorry, I paste, so it's better if you concentrate on that anyway. That's good. Okay.
To give you an indication.
Okay, so right. What we've done for this is we now do an approximation. Okay, and the approximation may count shared pages more than once. So it may give it may look like things are over the cap. Then they're larger than they are. So what we do is we do an approximation, but the approximation is very fast. We don't lock things down. If the approximation shows that we're over the cap, we automatically fall back into getVM usage. Okay, and we've changed PRStat to do this approximation, and we've added an option to PRStat, uppercase V, minus uppercase V, which basically says, I don't care, do the getVM usage, and let the performance suck while I'm doing it. Possibly suck. Maybe it's fine. Okay. And I will. Is anyone asking questions in Twitter?
No,
not even anyone there. See, this is what happens. I had 2 million people were going to come, and we were like 25 minutes late. They all went home.
They're all there. It's just a very clear story. That's why
it's so clear.
Yeah.
They're either bored out of their minds. They're completely lost. Solaris, what's that? I thought this was going to be a talk on the Illuminati.
Yeah.
How the cloud is going to help your business.
All right.
33 current people watching the stream.
There are 33 people watching this stream. Okay. 33 out of them. Okay, that's all right. We started late. What do you expect? Okay, now. So some enhancements we've made to SVCS and svcadm. The -Z option. So you can look at the services for a particular zone.
Nice.
Okay, we have lots, and like I said, we run lots of zones. So you want to look at the services for a particular zone, you can specify this. Minus uppercase Z shows all zones. So here I'm running -XV, but I'm doing it not only for the global zone, but for every zone in the system. And I get a prompt back, which implies everything's fine as far as SMF is concerned. Here, the next one I do a uppercase Z, uppercase L. The uppercase L is the one I want to talk about here because it shows you the log file. This is an addition. All right, kind of handy. Well, I think it is anyway. In fact, I think it's really handy. But here I'm showing the log file for the network, for the SSH service in all the zones that the service is in. Here I'm using -Z with svcadm and enabling rlogin. We don't ship telnet, by the way, so I couldn't enable telnet. Not there. You can also use -Z with svc prop. I'm doing that to get the rlogin properties for the zone that I just enabled rlogin in.
There's no capital Z for svcadm or svc pro.
Could you repeat the question, please?
The question was, is there no capital Z, uppercase Z for svcadm and svc prop? No. So in other words, the question is, could I use svcadm minus uppercase Z enable, and it just enables the service for everybody? Not that I'm aware of. No, I don't think so. It's an idea. I don't think so.
No.
Okay. I think if it was there, it would be in the slide. But maybe I'm wrong. Maybe I just missed that one. Okay. And additional zone enhancements. Okay, so there is the Joyent branded zone. This uses a sparse root model. So at one point, actually, Sun got rid of sparse root. And I think Oracle, in the meantime, has brought it back. Anyone know about this? Do people know what the sparse root is? So you share, basically, the root file system and /user are shared across all zones, global zone and everybody. I should also mention, well, I think I'll get to it, but root and user are in a RAM disk in our system. I'll come back to that in a little bit. So the Joyent branded zone, this looks very similar to the Solaris branded zone, but again, sparse root. And we have something called a KVM branded zone. And the KVM branded zone runs one process, QEMU. There are no privileges, no permissions to do anything else in the zone. So you can't break out of QEMU and exec a shell. You don't have exec permissions. The only thing you can run is QEMU. QEMU is where you run the virtual machine, Linux or FreeBSD or Windows or whatever.
But you can manage all the QEMU parameters through zone CG.
Actually, you can, but we have another command for that. I'll come to that later. Okay, we have a command called vmadm. Okay, we'll get to that a little bit later. So I should mention right now, you'll find that with this you will never actually run the command QEMU by hand, and you really don't want to, probably, because I don't know if you've seen it, but
yeah,
it's it's a one-liner that's 10 lines long. This does it for you. What else? We have fixed many bugs in the zones code, specifically dealing with zone shutdown hangs. So you shut down the zone, and for some reason, somebody gets stuck in a CV wait, and you can't kill it, and it sits there. The zone won't go away. How do you get rid of it? You reboot the machine. So we fixed a lot of these problems. And we have a zone-aware wall. So if you're
Who uses wall?
Yes.
Well,
For shutdown messages.
Okay, well, if you use wall, we have a zone-aware one now. So if you're in a zone and you wall, you're walling to other people in the zone. Okay, as opposed to everyone on the system.
Makes sense.
All right. CPU bursting. So, different topic. Okay, it says this is a mechanism that allows a zone to go over a baseline CPU usage. So I actually I have a colleague who, hopefully he's listening. He's one of the 33, and the other 32 of the 33 are other colleagues.
41.
Oh, it's 41 now, so they called up other colleagues, and so Max is talking right now. Can I-
44.
Can you see if I write here?
If you do it big
If I do it big.
and in light, please.
You mentioned your
And
colleagues.
this is
know
my
they're
favorite.
44.
This is my favorite thing. Wow. Because I don't see any eraser. So the professors bring their own erasers. Aha. So I have a colleague in beautiful and expensive Geneva, and he has a graph. This is CPU usage, and this is time. Too small?
Could you put on the right, please, on the desk? It's the small screen with the...
Lights?
Yeah, exactly. That could help somewhat.
It's just too small.
I think so.
No, the contrast is not enough.
Oh, the contrast is not. You know, I brought a Wacom tablet with me, and I could do GIMP, but I don't want to spend more time doing setup stuff. So,
Can you zoom the camera maybe?
Yeah.
Okay. Let's not go there. Video is good.
better? Better? Okay, now, so what people, when they talk about bursting, this is, okay, good. They talk about bursting a lot of times. What does that mean? You know, we tell people that if you use Joyent's Smart Data Center and you buy smart machines or virtual machines, you can burst the CPU. And so what most people do is, for bursting, is they'll say, okay, you can't burst past here. Oops. You can't burst past here. So what happens is they're running along, everything's fine, and then they come up here, but they hit this level, and that's as high as they can go because they're not allowed to go past that. And then they're running like this, and they come back up here, but they can't go past that. And what they might want to do is actually do this, but they can't do it because this is burst. So what do people do to fix this? Well, it's very simple. Obviously, the burst value wasn't large enough. So you move the burst value up here. Now they can burst, but then they never actually reach this value. You make it so high that of course you can do whatever you want. So we don't like it. It doesn't work well for us. So what we do is we have a new parameter called the CPU baseline. This is a zone property, and this is considered a normal level of CPU usage. And the idea is that if you go over the baseline, you're bursting. So we will still have an upper level on CPU usage, a cap. Then we'll have a baseline value. So, if you go over the baseline, you're bursting. You can't go over the cap. And what we'll do, if you're bursting, is we have a value, it says CPU burst time. And this isn't, I'm going to read this because I can't think of a better way to put it. So, number of seconds a zone can run at the cap before being capped at the baseline value. So if you're up here if the CPU burst time is 10, you can be above the baseline for up to 10 seconds. If it's 10 seconds and you're still above, your cap is moved down to the baseline value. We only do this if there is contention. So if there's nobody else in the system, you can do whatever the hell you want.
Up to the CPU.
Up to the cap. And the cap values, basically, we do a value of 100 is one CPU, so it's basically a percentage. So a value of 350 would be 3.5 CPUs worth. All right. So once you go over the baseline value, you can stay over for burst time, and then you go. Your cap gets moved down to the baseline value. You can stay at the baseline value or less, but you have to wait for burst time seconds before you're allowed to go over again. All right.
Is the baseline some sort of minimum performance guarantee you have on the system?
No.
That's the minimum performance you would get under contention.
Under contention,
Yeah.
would be the.
Yeah.
Actually,
But
no, that's not even true. We use something called the fair shared scheduler, and we use CPU shares. So you get a minimum based on ratio of all the zones that want to run at the same time based on their CPU share. It's not the same as this, the baseline. The baseline is just over it. You're bursting. You're considered bursting.
Mm-hmm.
So baseline value might be 50. So it's half of a CPU. You need more than that. Great. Go ahead. There's no contention. Go on as long as you like. All right. By the way, I should mention that right now we've got CPU burst time to 0. If you read, 0 means burst indefinitely. So we have this. The software works. We're not currently using it in-house. All right. Go ahead. Question.
It says there are spiky zones remembered time of the crew. Does that mean that the zone CPU burst time is the total amount of time you can go over your baseline for the duration of the process?
No. But I think the next slide will.
Okay, then one other
I'm
question.
hoping explain that.
Can I choose what type of CPU I run on? Because one CPU is, well, it just depends what sort of CPUs you have.
No, not well.
You repeat the question.
I should repeat the question. So there's two questions. One of them, can you repeat it? The first one, because the second one.
The first one is-
I'm going to forget in a minute too.
Is the CPU burst time the total time you can be above the baseline for the duration of the process?
Okay, so is the CPU burst time the total time that you can be above the baseline for the duration of the process? No. Okay.
Okay.
Burst time is just if you go above the baseline, then we start counting burst time. And if you hit burst time seconds above that whole time above, then your cap gets lower. And then we basically decrement every second until you go back to 0, and then you're allowed to burst again. Okay? Now the other question, can you choose which CPUs you're running on? Well, I'm going to assume this is a general SmartOS question, and of course. But I want to make sure I understand your question. I mean, I can always use pbind, right?
I get 100% of one CPU, that's the hard cap.
Right.
Right.
100% of one CPU, which may be 50% on one CPU, 3% on the second, 5% on the third, but the total is
It doesn't
100%.
say anything about how fast, how many clock cycles do I get? How fast is the CPU? Is
No.
it a 386, or is it a new Xeon, or is it?
Doesn't matter. That's going to be my answer to that.
We'll get back to that later.
We can come back to it. So in case you missed this question, for those playing at home, the question was, it doesn't matter, or actually that's my question, does it matter? Which CPU is it, are you running on? And how is this affected by that, I guess? But I think it doesn't actually matter.
Well, if you start running on T CPUs,
On-
Spark T series, then
Spark.
it really matters.
Why?
Well, if you can end up on a T3 or on a T2 or on a T2 plus, there's a big performance difference between those.
Yeah, but this mechanism, we can take, yeah, this,
Let's take it
this
offline.
it sounds interesting, let's talk later. All right. I wouldn't be surprised if someone answers, but,
I have another question from the stream.
oh, you have the question
Yeah.
from the stream, go ahead.
How many zones / customers do you typically get on a single SDC host? So how many zones can you host?
We don't, okay, so the question for everyone to make sure you heard is how many zones / customers you get on a typical SDC host. So a typical SDC host might be 24 processors, where a processor is PSR info counted. Okay, so cores, I don't give a shit. PSR info shows you 24, there's 24. And maybe it's got 128 a gig of memory. Okay. We do not over provision memory. Okay. So that's the way I'm going to answer that question. So if we have a customer that says I need 100 512 meg machines, we'll put all those, we could put that 100 machines all in the same box.
Right.
We could. All we do is we have an algorithm that determines how to provision, and it's basically memory based. And I can't give them a typical number. I can give them some upper bounds, but it's how much memory you got. How much memory you got.
Max,
Yes.
could you put out the light again?
I'll turn it off.
Yeah, great.
Okay.
One more question.
Yes.
This whole burst stuff baseline, did you build that build it into the scheduler, or is it also running as a separate process like the memory gap?
It's in.
Well,
It's
maybe a
interesting
better
because I
question.
was just looking at the code, actually, in the airport. It's in the kernel, so this is not a user.
So it's
level
called
thing.
every time the scheduler is called, this is also taken into account.
No, it is. I think. Well, no, I didn't look at it that closely. I was looking for something else, which I don't see here. But no, this has to be running in the kernel because otherwise you could go over the cap.
Yeah, but you can also go over the cap with memory, so.
You can go over the cap with memory.
But
but
that's
it's
why
not-
I'm asking.
It's not running in the kernel. This you cannot go over the cap. I'm positive it's in the kernel. CPU cap, CPU underbar cap .c maybe. User source UTS Common OS. You know the source
Yeah, well,
code.
yeah, I know where it is.
Yeah, I think you want to look there.
CPU cap.
I think it's CPU cap.c or CPU underbar cap.c.
Should be able to find.
Okay, now, where's it? RCAP. Look for it, you'll find it. Okay, so here I'm just dumping out, here's the zone. Burst time right now is 0, it hasn't gone over, it's not over right now and hasn't been over for long enough for the burst. Actually, the burst time value is a parameter, it's 0, okay. baseline value 40, the cap is 350, and I include CPU shares, which is again used for the fair shared scheduler, which is I think 1K, 1024. All right. Some case stats. And this might help with your question just a few minutes ago. Okay, so the case stats, I'm changing the burst time for zone 87B55 again, and I'm setting the burst time value to a 10. Then I dump out the value, and then in that zone I do some compute-bound stuff. And then I go ahead and run the case stat and grab the caps for this particular zone. The zone instance was 895, so I'm specifying these caps. Above base sec is is it 20? Above base sec 243,038. Yeah, this gets incremented. This is the code I was looking at. I was mistaken. And I looked at it because I wasn't sure about this stuff, and now I'm not sure again. Now, above sec gets incremented when you're above the cap. And it gets decremented when you go back below the cap. Or if you go above the cap and you go above the burst time seconds, it will, remember, it'll set the cap back down at the baseline, and while you're at the baseline, the value gets decremented. So the value gets incremented and decremented depending on whether you're above or below the cap. That's above sec. Baseline is the value 40, so you get a little under 50%, you get 40% of the CPU. Below sec, how long you've been running. Below the cap, total. Oh, and above base sec is how long the zone has been running above the cap total.
But it says above sec 23, but the bursting limit sec is 10.
Yeah, I'm
So
trying to
either you just
understand
change the
that,
value,
too.
or this is impossible, isn't it?
Yeah, I'm trying to understand that also.
You just changed it to 10.
Yeah, I just changed it again just before.
But it says for a bit. I don't know how long a bit is. But
Yeah, well, 10 or 15, long enough to type in some DD commands to get it to loop. Well,
yeah, I hate to poke a hole in a good story, but
well, no, look. I didn't tell you what I do for a living. And I'll tell you one thing I do for a living. I teach. And you have enough information to figure this out.
definitely.
Okay. Report back. Because I'm not going to answer this now unless you want to sit here and wait for me 5 minutes while I look at code. I'd have to look at the
It's
code.
more fun if I
I
do it
looked
myself.
at the code before because this is the particular thing that I got stuck on. When I was looking, I went over these a couple days ago and I got stuck here and I'm stuck again. And I did look at the code and thought I had it. But this I've got. This is clear. This, still not there. All right. Okay. So now we're going to move into ZFS and things we've done for ZFS. We've added a per zone I/O throttle. I'll get into what that means and why in a few minutes. We've added dumping to a RAID Z pool. So you can get a crash dump, a kernel crash dump in a RAID Z pool, command VFS stat, and a ZIO stat command, which you'll see examples of in just a second. Okay, so the per zone ZFS I/O throttle. The idea here is that the problem could be one zone issuing many I/O requests can impact other zones. This is in particularly true when you have a zone that's doing a lot of writes. And this can impact other zones. Flushing a ZFS transaction group can cause all zone IOs to be impacted. So you got one zone that's doing tons of writes, and it impacts everybody else. This is the basic problem. And our solution is to implement per zone ZFS IO throttles. There is a blog that goes into this very nicely right here. So this is, all I'm doing here is I highlight what's in the blog and then go through a little example. So some requirements on the I/O throttle. We want to ensure consistent and predictable I/O latency across zones. How long do the transactions take? How long does it take to retrieve the data when you do a read? How long does it take to do a write? Sequential and random I/O patterns have very different characteristics. Orders of magnitude difference in latencies, for instance. So we don't track I/O operations or throughput. The throttle tracks latency. How long do the operations take? We think that's the important thing. If there, so another requirement. If there is no contention for the pool, you get all of it. Do as much I/O as you want. So what we do for this is we have a metric, utilization metric, which is just arithmetic calculation, number of read system calls times the average read latency plus number of write system calls times the average write latency. And the mechanism, there's a mechanism to throttle zone I/O requests when the zone use goes over a fair share. So it's similar in flavor to the fair shared scheduler. You get a what's called an I/O priority, and you share in ratio with other zones and whatever their priorities are. It's the basic idea. So we compare I/O utilization across all zones. If a zone uses more than average I/O utilization, where average is, again, the utilization is calculated by the calculation at the top, and the average is basically the ratio based on your I/O priority. Then read-write system calls from that zone get delayed up to 100 microseconds. So we add a delay to slow the guy down. Okay. Each zone has a relative I/O priority set via PRCTL or zone config. And okay, now this part of the talk took me about 2 weeks because I could not, and I had other things to do. Okay, so I didn't spend the. Actually, I spent the last 2 months just working on this talk, and that's probably what some guys in Joyent think. But so at any rate, it took me a long time to get this right because what I did was I was trying 2 different zones, and I had one which was just reading a large file, and I had another zone where I was doing random I/O. And I kept thinking, okay, if I give the random I/O guy better priority, higher priority value, it'll go faster. If it's got higher priority, the disks will just move faster for that guy. It took me a long time to wait. This is ridiculous. Of course, the disks aren't going to go any faster. The guy was going as fast as the disk could go. It's all completely random. And another mistake I made was I was doing all reads. So, I mean, what this is supposed to help with is writes. And in fact, I didn't realize that I probably should have been doing writes. Random writes would have been good, because that would have generated large transactions. And the other thing I found was a lot of times the amount of disk I/O was close to 0 anyway. Arc. So I was thinking, how the heck can I show that this does anything? So eventually, I made 2 zones and gave each zone a 60 gigabyte volume file. And then we didn't have that much memory in the machine, so 60 gig was going to eat enough into ARC so that And then I had both zones do sequential I/O, sequential inputs. And then I started to see differences. It's not, if you had one zone with 10 and the other one with a priority of 1, you're not going to see 10 times faster. In fact, sometimes the guy with 1 is going to be faster again because of arc. All right. So at any rate, here I am dumping out the priority for 2 zones, both of them zone 34 and zone 35, both of them with a priority of 1. And I've got these 2 zones, and they're basically DDing a large file to dev null. I think they're using an 8K block size. Just DD a 60 gig file to dev null, and they both sit in a while true loop doing this, so I can look at the stuff. And here I'm running the ZIO stat command without the uppercase Z. ZIO stat gives you read latencies, but only for the zone you're running in, or the global zone if you're in the global zone. With the minus uppercase Z, it will show you read latencies for all zones. And I'm just picking out, I grep for zone because I want the header, that top line, and I'm grepping for the 2 zones I'm interested in, which don't match the 2 I'm showing up above, but that's what happens when you keep playing. And I should have changed the 34 and 35 to be 36 and 37, obviously. No, but they should match.
The UUID still matches.
Yeah, the UUID still matches. How come those numbers are different?
You rebooted the zone. The zone ID increases when you reboot. That's the zone ID.
Yeah,
right?
you know, I may have rebooted the machine. The machine itself, not the zone. I'm not sure. I don't recall rebooting. But yeah, these must be the same zone. The UUIDs are at least, yeah, they're almost certainly the same machines. At any rate, you see they're both running 520, 550 read operations, about 66, 68K reads per kilobytes read per second. And both of them are 87, 86% busy. So these both have the same I/O priority. Here I'm doing it again. I'm doing VFS stat. Now VFS stat, again, without the minus uppercase Z, just shows you statistics in the zone you're running in. With the uppercase stat Z, it shows you all zones. And the important numbers are these last 2 columns, second to last 2 columns. Delays per second and delay time. So both of these guys are being delayed by the throttle. Okay, and this delay time is in microseconds. So the maximum delay time is 100 microseconds. So they're both being delayed pretty heavily. There's other things on this machine. That's what this implies. One of the things. So now what I do, I think in the next guy, yes, I set one of the 2 zones to give it a ZFS I/O priority of 10. And here I am running ZIO stat, and you can see that the guy who I gave a value of 10 to, he's getting in a bit more often. Although you'll see I've got ... before that. Well, if you look a couple lines before, you might have seen that the other guy was getting in more often. It really very difficult to measure this stuff, to see effect. May have been better if I tried to write something that does random writes that generated more transaction group activity. All right, yeah, you can see here that the first guy is delayed 826 times in a second, and the delay value is 100 microseconds, and the second guy isn't getting delayed at all. So he's getting in more often.
But the first guy gets almost twice the performance.
Yes, I know. Yeah.
There's too many numbers on there. Forget it.
Wait, so ZIOstat is the pool, and VFSstat is the file system. So VFSstat is basically file system reads and writes. So stuff that's ARC, it's going to count that. Yeah. So yeah. Yeah, the second guy is getting the disk more, but I bet the first guy is getting ARC more. I suspect that's what's going on. Oh, I'm sorry, I got to be over here. All right. Now, okay, so I think this. Oh, now I understand. Somebody reviewed this and said this slide was twice, and I couldn't find it twice, but now I see it. The only thing that's missing here that I didn't talk about earlier, KVM we use. The KVM virtual machines use ZFS volumes for the disks. We think this is a big win. I've seen it. We had a guy copy he FTP'd a large file into a Windows virtual machine, and then copied the file from one place to another, and the copy was really fast, like faster than Windows would do a copy, because it's all on the ARC. Done.
Yeah.
Really, really nice. Okay, so new K-stats. Okay, so there's a bunch of new K-stats that have been added. Move on. Okay, other topics. Should we just keep going until we're finished? Or are we going to take some kind of break?
There's a planned break between this and your KVM story, but if you want to take a break now, that's fine with me.
Let's take a break now because we're about halfway through.
Okay, then let's do like a 15-minute break or so. It's 20:55. So let's start again then maybe at 1:15. It's a 20-minute break.
That's pretty long.
Is that long?
Yeah, these guys came here from, I mean, you came from, where the hell do you live? Germany?
Almost. Yeah.
All the way from The Hague, which is
From The
60
Hague.
kilometers.
So I came from Geneva.
You've already seen it.
And I have already seen it. All right. So 10 minutes is 10 minutes. Is that okay?
Yeah.
10 minutes.
Okay.
Okay, we pause for 10 minutes. But don't turn anything off unless you're sure you can get it back.
Nu heb ik geen niks meer aanstaan met dat.
I was in Amsterdam data center.
Wat is het nou?
In Joyent's Amsterdam data center.
Nee. Where is Joyent?
Where is Joyent's Amsterdam?
Wait a minute, guys. Exactly, we're still recording here.
Ja, want je ziet toch wel waar we
Installed.
Ja. We hebben dezelfde vorm, bij mij weet het nog.
I haven't seen
We hebben wat eruit het leek, maar we hebben dat de CPU.
I don't think I've seen any of it.
Hij gebruikt ook broekzak voor mij.
We weten alleen niet waarom.
No more recording?
No, still recording.
But still, okay. Just no masturbation.
Hij is gewoon pinging, zelf op koude snap het ook wel. Maar dit mij is dat niet.
Ik ben een waardige demon.
Ik zou gewoon op die aquarium teruggaan, dat is hier wel achterkomt.
Sorry for all that.
Oh, no, we pay them now.
Yes, I know that. Yeah, that part.
So you were installing like for Joyent? Okay.
Device which is needed to be quite from the next connected. I couldn't come out with it.
Because they're in California. Yeah. Okay. How do they know you? Oh, I see.
The guy who runs the company knows us.
I see. I understand.
So he said, I need people who can do up to the government. But the recording is still on. So I'm moving and
Yes.
it's not 6 cabinets. This is 25 ounce, 30 ounce per cabinet. So it's about 1.8 gigabytes. All 15 cables.
I'm ready. That's it, right there.
Screensaver.
Uh-oh.
Ja, maar kan winkel.
Hey, je left me
Ik hoor, er komt iemand langs jou.
Gelukkig is hij niet ermee.
Ja. Die worden wel heel langs.
Breed of diep?
Tussendoor gepast.
Dat is een beetje business standaard. Ja, ik zeg altijd wel.
Wat we zijn verwend bij.
Ja. Ja,
Oh, de video's verstaan.
Ja, dat niet.
Ja, te gek. Ik kan hem niet echt verpassen. No, it's okay, next. Sorry.
Video, everything's there.
Oh, hey, you sweet. Dat is raar, hè?
Hi. You're back.
Okay, so we run a live image from a USB key. So you boot off of a USB key. The root file system uses a RAM disk, is mounted read-only, it's more secure. All the disk space is used for zones. We do put opt-var and etc zones in the zones Z pool. So these are persistent. But okay, and you can add services, make services persistent by got a mechanism that will look in opt custom SMF, and you have to create this directory if you want to add your own service to the machine. All right. I didn't like this when I first started using it because I would do things like well, one of the main things I tried doing that I had a hard time figuring out was I'd build a new KVM module. How do you get that? How do you boot? How do you get it to boot? Because you can't put it into user kernel or kernel because it's read-only. And if you could put it there, it would disappear when you reboot it anyway because it boots off the key all the time. But I've gotten used to it. It's great. Okay. There are ways to do what you need to do. All right. Okay, dynamic VNICs, we create and destroy these when zones boot and halt. Each zone can have a VNIC created by the global zone with a friendly name. We use net0 for, pardon me, a lot. We've also enhanced the ADM, DLStat, and flow ADM commands with zone support. I don't think I'm going to do anything with these. I'm just mentioning that we've done it. Core ADM enhancements. We've added support to limit the number of core dumps, and also added %Z name pattern for the zone path. All right, and if you don't know what any of this means, RTFM.
Maybe RTFM, but what happens if you reach the limit?
I don't know. I think we'll start dropping them on the floor is what I think will happen.
Well, no one uses them anyways.
Sound volume seems to be lower than
I can't do anything about it.
before.
It's full.
It's all the way up. I can talk louder.
I'll talk into the mic, that helps.
Talk into the mic. Okay, how's that?
Too loud.
Now, so dtrace enhancements, LL quantize, log linear quantization. Read the fabulous blog by Brian Cantrell about this. Okay. VM regs is, I use this later in the presentation to retrieve a register from a virtual machine. Okay. Trace mem action takes a dynamic size argument. Yes. No one uses dtrace here, but I've wanted this for a long time. So what this does is it basically you can give it a variable and say I want to give me this size. In the past, you can only give it a constant. Okay.
Max,
Yep.
we are dtrace users, but lazy ones. Since you talked to Brad and Greg, is he going to maintain the dtrace toolkit? Could you repeat the question, please?
Yeah, the question was, I talked with Brendan Gregg, and will Brendan maintain the dtrace toolkit? And I'm not going to really speak for Brendan, but I will say that Brendan is definitely wants to do that.
Okay, cool.
Okay. How much time he has to do it is another issue, but I'm sure he wants to. All right. We've got the two upper and two lower subroutines. LL2 STR takes an optional base, so you can specify you want base 8, base 16, whatever, hex, whatever. We have added STT probes for ZVol reads and writes, ZFS volume reads and writes. The dtrace helper actions maximum is set to 1024. I have used this maybe 3 years ago when I was doing some STT probe stuff. You're on your own. Unregister of defunct provider probes. So you, for instance, use the PID provider, and you traced all the functions within a particular process. The process exited, and because all those probes for all the function entry and return, they were all enabled. They weren't getting cleaned up. It was eating up memory. So now, when the function exits, we can unregister. We can clean up these probes. All right, so just some dtrace enhancements. MDB enhancements. You guys all use MDB, right? All the time. I do, or did. No? MDB?
Memstat?
KMAstat?
No, Memstat.
Memstat,
Yeah,
colon
colon
Memstat, yeah. Okay, so that's the one that
Yes,
most
and-
people at least know about. Okay, so we have disassembler support for Intel VTX instructions, because when I was working on KVM, you'd hit this machine would panic, and I'd want to look at the assembler code where I was panicking, and you'd get these illegal opcode messages or unknown opcode messages from the assembler. So this assembler now understands all the Intel VTX instructions: VM read, VM write, VM enter, VM clear, VM launch, VM resume, etc. 16-bit disassembler support. What the hell do you need 16-bit disassembler support for? KVM, because the BIOS apparently runs 16-bit assembler code.
Actually, it does, because an x86 CPU still boots 16-bit.
Yeah.
And then it switches to 30 or 64-bit mode.
Yeah, so we had to add support for this in MDB to figure out so you could figure out what was going wrong when it was trying to boot and wasn't coming up. : printf. Like : print, but formatted print. Okay. Now I just want : print in dtrace. Tab completion. Start typing in the D command or whatever, tab, and it completes it for you. Ugrep and kgrep for sizes less than 4. Okay, great. ::scale HR time. I don't know what it does. I haven't tried it.
Small question about the tab completion. Does it also work for kernel variables?
That I am not sure. No, because we.
I could figure it out myself.
Yeah, and it's actually I'm interested, but no, not now. Find JS objects. It's got to be JavaScript. Okay, another Java guy. NDB8. This is for Node. You guys know anything about Node.js?
Are we actually talking about the JavaScript or?
Node.js. It's event-based JavaScript. I really don't know it. I'm sorry, but it's lots of people really like it. It's fast. It is fast. It's neat. It's single-threaded, completely event-based. All right. Deirdre, are you there?
No, she's in the team.
She's in the team.
She thought it was only lasting 1.5 hours.
www.node.de or node.org. Something like that. Take a look. But I think NDB8 has to do with Google's V8 engine and Node. Colin Walker for JavaScript frame and Java stack. There's an MDB API function for iterating object symbols. This is for those of you who like to write your own D commands and walkers. Move on. IPDADM. Interrupt packet disturber. I think is what it stands for. It's a utility for simulating pathological network by inducing packet drops, delays, and corruption. And you specify the percentage of drops, or the percentage of delay, or the percentage of packets you want delayed, or the percentage of packets you want corrupted. And this can be used on specific zones that have exclusive IP stacks. If you use it in the global zone, and it affects all zones with shared IP stacks. And here I'm running it in an SSH session and saying I want 10% corruption, and my SSH session died. Pretty much as soon as I hit return. So I tried it later with drop, but I couldn't remember which netstat command will tell me about dropped packets, so I figured I'd leave it as an exercise. It's an interesting little tool. Driver updates, module updates. IXGBE was updated. These are drivers. Intel, Gigabit, Ethernet, driver updated. We incorporated fairly recent ACP-ICA code from Intel. And we've ported the open IPMI driver from FreeBSD. All right. We use that actually for getting things like console access. Some other stuff. There's been many fixes for handling error cases preventing zone shutdown, which I've already mentioned. Fair shared scheduler fixes to prevent zone starvation. We've made cron so that it looks both in etc and /var in particular /var for user-defined cron jobs, because if you added a cron job in etc and you rebooted, it's gone because etc is RAM disk, it's not on USB key. var is in the zones pool. There is, I don't know if Oracle's fixed this or not yet, but there is a scaling issue with IP. The DCE cache, the DCE cache is basically a cache of half MTU sizes for every IP address that comes to your machine. And so I figured out what the problem was. I didn't make the fix, but so what would happen is we had a customer and their machine over time it would get slower and slower. Eventually, it would just kind of, it would not be making very good progress at all. Things would start to fail. And we didn't notice at first that this was gradual, but eventually we figured it out. And what was happening is that this cache just gets larger and larger and larger. And there is code in Solaris to clear the cache, but that code only runs when you're under memory pressure. But on the machine with 128 gig of memory, you just weren't getting under any memory pressure, so the code never ran. So eventually you'd have a cache of 30 or 40 million entries. And this 30 or 40 million entries was in an array of 1,024 hash buckets, or no, 256 hash buckets. So you'd hash, and you'd do a search through a couple million entries, and this was being done at interrupt time. And it was being done elsewhere in the system, so things would just back up. The networking got so slow that things would fall over. So we've got a fix for this. We reduced the service management facility's resident set size, which is really useful when you when you want to run 100 zones on the machine. We made the SMF smaller. Because with 100 zones, every zone has its own SMF instances. So we made this stuff smaller. There's lots of miscellaneous bug fixes in the system, and finally, the good stuff, KVM. All right. So this part of the talk is now on KVM. So we basically consider SmartOS to be a hypervisor, and you can run SmartOS zones, but you can also create zones running Linux, Windows, etc. using KVM. So what we're going to do is KVM was ported from Linux and released last August. And I'm going to go through a brief overview, a few implementation details, some added commands, and possibly a short demonstration. All right. So I wasn't sure what I should do here because, to be honest, I probably know more about how this works internally than how to administer it. All right, you guys, I started doing the port. Okay, so when I joined Joyent, they had me at first looking at system hangs, and then I started looking at other dumps, and in the meantime, they hired this guy named Brian Cantrell, and Brian brought a bunch of other people in, and Brian said to me, you know, are you interested in doing KVM? And I said, oh yeah. And he was very good about it, and he said, well, we don't know how long this is going to take, and you know, people were coming to him, how long is this going to take? No idea. So KVM is in SmartOS, it's about 30,000 lines of code. It's larger, I believe, in Linux because they support some other. I don't know, it's clearly it's larger. At any rate, so I started doing the port, and I worked on it for several months, and I got it to a point where a virtual machine would come up, it would execute 4 instructions, and fall over, usually taking the entire system with it. So I had literally, I looked at hundreds of panic dumps, hangs. So it was a lot of fun. So I wasn't sure if I should talk about this part of it, or so. The result is I'm going to talk about both of them poorly. And I'll talk a little bit about the implementation. I'm going to talk a little bit about administration. So a little bit about implementation because for me it was interesting, and a little about administration because for you it will be useful, hopefully, if you're going to look at this stuff. We basically run as a device driver. One of the things that I did when I started this, I said I do not want to change anything in Solaris. And we didn't. Now I started to say I got it to get up like 4 or 5 instructions and fall over, and then Brian Cantrell and a guy Robert Mustaki, they joined me, and the development just went much faster. Basically, once you got past those first 5 or 6 instructions, everything just started working. Okay, the guys who did this in Linux they've got to be brilliant, because Linux, how do you debug stuff in the Linux kernel? This is in the Linux audience. You guys don't know. You're the way I am. They use print K? No way. How did they debug that? At any rate, so it runs as a device driver. The user level is QEMU, and this is mostly unchanged from Linux. And there are some things that we just couldn't do the same way. There's some changes we had to make, but we tried to use as much as possible QEMU unchanged. The version of KVM is roughly from March of 2011. I don't remember the version number, but roughly March of 2011. We do try to keep track of changes that are being made, but only pull in things that we think we need. I mentioned already, QEMU runs in a KVM branded zone. It uses ZFS volumes for disk space. We use VirtIO drivers in the guest OS for disk and networking, same as Linux KVM. In fact, these VirtIO drivers are from Linux. We don't do anything with it except use it. It says no changes made to the Illumos kernel for KVM. We added kstats and some dtrace probes. Actually, a lot of dtrace probes and quite a bit of kstats. I had to draw some picture. What should I say about this? So the virtual machine basically runs in QEMU. And QEMU makes call. What it basically does is it opens a KVM device and then does IOs. And it'll do a bunch of setup. It'll set up the memory space for the virtual machine. All of this is in the QEMU address space, user level. Then it does a bunch of I/O controls, and eventually it does an I/O control that says, run the virtual machine. And then that ioctl in the kernel sets up the registers, and then executes a special instruction, VM enter instruction, basically VM launch instruction. And VM launch starts running the virtual machine with the registers that have been previously set up. It runs the virtual machine until something happens, which causes the virtual machine to exit. Something might be an interrupt, a special instruction, system call, trap. Various things can cause the virtual machine to exit. When the virtual machine exits, the KVM driver starts running again to handle the exit, and it typically re-enters the virtual machine. It resumes the virtual machine. I spent a long time looking at this stuff. Basically, 1 year of doing nothing but staring at a screen, which is why I'm here now, is because I basically told Brian, look, I'd much rather be talking. This I like, but I don't want to do it all the time. And I lost the thread. All right. There's a reason I said that, but I've forgotten it entirely. So at any rate, yeah, it will. I'm going to go on. All right. So I wanted to show some very high-level picture. Okay. Okay. So one of the things I did when I was spending all this time looking at this stuff is that there were a few times when I said, is this really the right way to go, KVM? So then I took a look at Zen. And what I saw in Zen, I said, this is a mess. It's everywhere. It's KVM, it's all in one place. Zen, it's like, oh, there's Zen code here. You look in various, I don't know, you guys look at the Zen stuff at all? Most of you don't look at code, I don't know, but if you look at the Zen code, it's kind of scattered all over the place. I didn't like this. Yeah, and maybe it works great, I don't know. I don't want to debug that. VirtualBox, yeah, I say performance is an issue. What I really originally said there is C++ in kernel, forget it. But then I thought, oh, some people like C++. Well, okay, VirtualBox maybe is for you. KVM, no changes to the host or guest OS. It's nice. It's the right way to do the stuff. I'm curious, what is Oracle VM going to use? Is it Zen or Zen?
Yeah. With no plans that I know of using KVM.
Is that an
Or
open
anything
statement?
else. No, definitely not.
Just no, that's what he said.
You know,
Red Hat uses KVM now, so probably Oracle will as well.
Well, Red Hat's really into KVM in a big way.
Since this is so cleanly implemented, can someone pick the kernel module from your SmartOS and put it on a different version of Solaris and it'll run?
Yep, that's my view.
As a guarantee.
No, I'm not going to guarantee. What are you kidding? It will run. It won't cost too much for somebody to come and make it run. I don't think it should just run. I'm quite serious. Cool. It should run. On Intel. We don't do AMD. Somebody in Illumos is working on an AMD board. You know, you got to find somebody who has Spark equipment that would support, that has hardware virtualization in it. So I guess the T2, the T3 chips, they do virtualization stuff.
yeah, they do.
Yeah, I thought they did. So, but you have a lot of work there. Okay, so the driver has 29,889 lines of C code. Yeah, when Brian and Robert joined me, there was about 17 or 18,000 lines that had been ported. When I did the port, what I started doing was saying, how can I make this simple? Don't put this, don't put this. And then I realized, wait, I might need this. So what I started to do all over the place was I started basically, if I thought it was something that I didn't need right now, I had this kind of stuff all over the code. If XXX. So this was all over the place, and there's still some in there. But Brian had a really good idea for this. What he did was, he made these dtrace probes. So the guy's brilliant. He's just brilliant. He made these dtrace probes so that if you hit a bug, one of the things you could do is turn on the XXX tracing. And it would tell you, oh, you've hit this one probe 5,000 times in the last 10 seconds. Oh, maybe that's something we need to look at. Maybe we need to implement what's in here. Brilliant. It's simple. You hear it, oh, of course. But I didn't do it.
How did people react if you told them you were doing sample exploit?
All right.
Sorry, that's still recording. Yeah.
Yes, okay. Yeah, so a lot of the porting was translating from Linux to SmartOS. And a lot of that was, what is it? Mutex spin. Okay, we're going to make this Mutex enter, and we'll make it an adaptive lock, because I didn't see, there's only one place I think there was actual need for spin lock. If you don't know what I'm talking about, take an internals course. I teach internals courses, by the way. Now, okay, so some things were not so easily translated, so some of this stuff took a lot of work. All right. some of the low-level CPU, register handling, memory management code, some of the ioctl handling had to be changed. Some of the scheduling stuff was quite different. Oh, sorry, I got to be back over here. The code itself is organized fairly similar to Linux. It wasn't when I was writing it. I had two files. I think one was about 10,000 lines and one was 7,000 lines. I was just throwing stuff in and trying to get it to work. And Robert was really good about organizing. It looks really nice now. QEMU user level is about 661,000 lines of code. This includes support for Spark, ARM, every kind of processor you can think of. Okay, and this is again mostly unchanged from Linux. Some restrictions on our KVM implementation. The virtual machine memory is locked down. We do not page the virtual machine memory. Doing that, what they do in Linux is they added these things called MMU notifications, which were callbacks into the MMU, from the MMU system into KVM. It's nice in that it allows you to see. The problem is that if you start paging the memory of the virtual machine, you get a page fault. You have to handle it in two places. It becomes very complicated. And I just said, screw this. I want to get it. First of all, I want to get it to work. And second of all, I'm not sold on doing this in the first place because it's got to add a lot of overhead. And third, I don't want to change anything else in Solaris. So, and Brian basically said, no, we're not going to over provision. So forget it. He doesn't think it's a good idea. Intel with VTX. VTX is the special instructions. EPT is the expanded page table. It's what are called. They call them three-dimensional page tables. So it has to. This chip has to have support for EPT. Linux KVM will work without EPT. And in fact, I remember fighting with EPT for a while, and I don't know how it ended up. It's not in our port. If you do not have EPT, the processor won't work. Okay, finally, there's no kernel same page sharing. All right. So there's some people that would like this because you would again allow you to over provision in effect, but we do not support it. It would require extensive changes to the rest of to the memory management. This is actually taken from a comment in kvm.c. There is a very nice long comment by Robert on how the stuff works in the source code. And I like this little ASCII diagram, but I've actually already talked about this. You make an ioctl, you start running the guest. So the ioctl goes into KVM. KVM launches or resumes the virtual machine. Eventually the virtual machine exits because of some reason. I'll get to what kind of reasons there are in a minute. We check, can the kernel handle the exit reason? So you're in the KVM driver. The kernel handles the exit and goes back and enters the virtual machine again. Or the kernel cannot handle the exit, we go out to QEMU and try to get QEMU to handle the exit. If QEMU does not handle the exit, there's a problem. All right. But our stuff it's running very well. We're running this stuff in production for 8 months. It works well. We've had glitches. But not many. Okay. Here I'm going to create a KVM virtual machine. And this is running on SmartOS. I need to, so this is a fresh installation of SmartOS. It's not actually installed again, it's running as a live image. I add this file so I can pick up what are called data sets. A data set is basically, here a data set is an image. I update the image, which basically says use the repository, if you will, that's in var.db imgadm sources.list. Then I list available images. You'll see there's some SmartOS images. So basically you can provision a SmartOS machine. You can provision a Linux machine. There's a Linux image. And so I decide to import the Linux image, and it brings the image across from datasets.joyent.com. I get some information about the image. You'll notice this is all JSON format. Tells me this is CentOS 6. Give me the size of the image itself. There's a lot more stuff here, but it's down here. All right. And I created a file called var.temp zonedef. And you'll notice this again is in JSON. And what I'm going to do is basically create a virtual machine using the image that I just imported in this definition. And this stuff, by the way, is all on the SmartOS wiki. Okay, there's how to do this. It's all documented on the SmartOS wiki. So I'm basically taking from the wiki and slightly munching things. So I'm going to use Google for the resolver, my default gateway. Now, actually, I'm not actually what I'm doing here is not actually being on KVM because I'm doing it. I did it on my laptop, running on top of some other virtualization mechanism. But I will show in a few minutes the real thing. It's going to have 512 meg of RAM, 2 virtual CPUs. I've got a NIC. I'm going to use 1088-8833 as my NIC. I've got a disk that I'm going to boot from, and it's that image that that you can see I'm listing up at the top, the UUID. So it'll boot off of this image. So now I create the zone. I create the virtual machine. Here I am listing it. It tells me it's running. So again, it's this vmadm command I mentioned before. So we don't use QEMU. There is a log file that vmadm generates that you can see the QEMU command line, which I will show, I think, in a minute. Okay, some commands we've added. KVM stat. This shows me machine exits, virtual machine exits. So I've got one virtual machine. This particular virtual machine has 4 virtual CPUs. Now, this is not being done on my laptop because I don't have KVM on my laptop. So this is on a real machine. So I'm looking at a virtual machine with 4 virtual CPUs, and you can see the number of exits from the VM on each CPU. This is running every 5 seconds. Exits due to halt instructions. Exits due to interrupt requests. I don't remember IRQWX. Exits due to I/O requests, memory mapped I/O requests, some more interrupt stuff, emulation. So occasionally we have to emulate something. It's all the emulation is done in KVM itself, not in QEMU. And extended page table violations. So the top 2 sets, 5 seconds apart, these are on a VM that is basically idle. It's not doing anything. Then I'm running a bunch of stuff that's I'm actually running a find on / and piping it to xargs grep foo. So I'm generating a bunch of stuff, and now you see a lot more exits, a lot more activity. In general, the only thing I want to point out here, and it may not make any difference to you, is the numbers here, smaller is better. The less exits you have, the better you're running. All right. We've added 66 SDT probes. These include entry and exit from the virtual machine, probes to look at emulation, and the XXX probes I've already mentioned. We've added access to VTX registers, and of course there are 1,478 FBT entry and return probes. A lot of code. Good stuff. Here I'm just showing an example, and this is showing me from between the time you start running the virtual machine until the time you exit, and how long I'm actually running. But it turns out that maybe a better probe would have been this one, KVM guest entry and KVM guest exit. So what this does is I'm using VM regs and I'm picking up the process of the virtual processor ID who is exiting. And I'm quantizing on it. So if you're not clear on this, looks like, well, I didn't run it. This one's much more interesting. You may not think so, but I think it is. You guys know what this is doing? So what this is going to do is when you enter the virtual machine, it's going to tell you the program counter in the virtual machine where you're entering. And when you exit, it tells you where you're exiting from. So if you had a symbol table for the virtual machine, you could find out where you're entering and exiting. You know, it's one of the steps towards the VFBT provider. VFBT? Mm-hmm. Virtual function boundary tracing. Cool. Tracing windows, that's just what I've always wanted to do.
We also tracing JavaScript.
Yeah. All right. So this just shows you, that you're entering and leaving. This is basically the same place very often. I suspect this is some idle loop, but don't know for sure. I didn't take it the next step, which was to see if I could figure out the symbol table.
So is there anything you can do against the virtual machine exiting?
No. The one thing you can do is try to make the time as short as possible.
Right.
But yeah, there's not really a lot you can do. There are some papers written by the guys who first wrote KVM, and there's a few others on how to minimize the exit time. We've got a way to measure it. We've done some performance measurements and compared with VMware, for instance, and the numbers, depending on what you're doing, look really good or so-so. Where we really look good is file system I/O, because ZFS just is a massive win for that. Okay, there's some case stats for KVM. Again, more numbers about exit reasons, basically. There's been some walkers added. This is really useful if you're debugging KVM. but fortunately it doesn't have any bugs, so you won't need to do that. You know, when I worked for Sun, I said the same thing. Sun stuff didn't have any bugs, so of course, and then what I taught was kernel crash analysis. All right. We don't have any bugs except for the bugs that happen.
No, that's somebody else's driver. So.
Yeah, right. Third-party software, it's buggy. It's the first thing you got to ask. Are you running that in a Windows virtual machine? No. We move on. Okay. So this, what I wanted to show here, I don't know if you can see it. Okay, so I do have comments. So you've got the /zone/4FDD blah 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 blah, and it's 10 gig large, and this basically contains files for the zone. This is where, for instance, log file for QEMU is. The vmadm command has a log file that it keeps here. So this actually you can CD into an LS. This is a file system. It's got a mount point. Then you'll see there is a boot disk. This is a volume. And you'll see a data disk. So you'll get two disks. One you boot from, one is the data of the virtual machine. And then there'll be a fourth mount point, actually, the cores directory, and this is basically where QEMU core files will be if it dumps core. Of course, it never does because it also has no bugs. So vmadm runs against a daemon, vmadmd. vmadmd is written in, and I think vmadm is also, they're both written in Node. So if you don't know Node and you think, oh, that sounds interesting, that may might be something worth looking at. You'll notice there's a log file for vmadmd, but there is also a log file for a particular instance. So vmadmd is all of the zones on the system, all of the virtual machines on the system, and the vm.log file that I've got in that cat line, that is for a particular VM. And if you look at that, right at the beginning, you'll see the QEMU command line, which basically starts about the fourth line on the screen and goes down to Cirrus. So you really don't want to do this by hand. This is all done for you if you run vmadm and use the tools we're providing. This could not open option ROM is a error message that always occurs from this particular BIOS. The BIOS is basically emulated. Okay. Tells me about CPUs. I've got 4 CPUs set up because virtual CPUs are set before. And it basically gets, and here it's exiting because it's now running, I think this was CentOS.
So at that moment it did the VM launch?
Yeah. Well, no. It did the VM launch. I think it did the VM launch where it says could not open option ROM or start BIOS, one of those two lines.
Because the BIOS is already in the VM.
Yeah, the BIOS is put in a particular location in the memory space of the VM. So if you read about, if you read Intel documentation, they'll tell you when the machine turns on, you go to this location.
Yeah.
And there better be something there that we can execute. Okay, so this is what I talked about. I added this on the plane because somebody I work with said, oh, you should have a summary slide. You can get it here. The slides are going to be on the wiki if they're not there already. And just to remind you, because I work with these great guys in Geneva that they don't want to be on the street. So if you know anyone who's interested, you can try a smart machine. And that's it. We're done.
And
Thank you.
Thank you very much for doing this. think it was a good experiment.
Yeah, I don't know how. I'm very, well. Actually, I'm not curious about the video because a 2.5 hour video. I'm just going to watch it. There's no plot. There's a video of me that people actually watch on the internet. I know they watch because I get email about it. And it was done several years ago, and I can't imagine sitting through it. Well, I've watched Brian Cantrell. You ever? I mean, I'll watch him in a video, but not too many people, I think, technically are that exciting to watch.
Maybe I've just been too lazy looking. What is the precise connection between Illumos and SmartOS? I mean, is Illumos just the base for your SmartOS distribution, or?
Yes. Okay, so we basically took Illumos, which I think was 151, build 151. Someone said here.
Yeah.
Okay. We took 151 and we modified that, and well, actually, they did the Illumos fork from that, and then we took the Illumos fork and started making SmartOS, and we contribute back, and we occasionally get fixes from other people in Illumos.
So it's two separate development trains, basically. I mean, it's not.
Could you repeat that question?
You know, the real question is well, maybe I should say the question is, there are two separate development trains, Illumos and SmartOS, and I would not quite put it that way. Joyent is developing SmartOS and pushing changes up to Illumos.
But Joyent is not Illumos.
Joyent is definitely not Illumos. Okay. There are other companies who are also using Illumos. Nexenta. There's a few others. I think there's one called Omni. OmniOS.
Yeah.
There's a couple others. Open Indiana, that's another one, yeah.
OmniOS is fairly recent.
OmniOS is fairly recent.
So apparently it still pays off to start your own operating system.
Good for you, though.
Yeah.
I think the operating system is great. I haven't really been following Solaris 11 at all, and haven't tried Omni. Haven't really run an Illumos. Is there? I don't even know if there is an Illumos distribution.
That's the reason for me asking.
Okay, I don't know.
When looking for that, for an Illumos distribution, I came at SmartOS.
SmartOS, yeah. Yeah, OmniOS is an Illumos distribution, and Nexenta has an Illumos distribution, or at least they use Illumos. I don't know.
The whole new user and stuff.
Yeah, that's right. That's right. Yeah. Same here. Okay. Yeah, I don't know who, if anyone, has a distribution called Illumos.
I think the closest thing you get is Open Indiana.
Probably the closest you would get is Open Indiana. Yeah.
All the stuff you put in SmartOS that is open source too, we can download.
Yep. KVM is all open source. All the changes we talk about are open source. Our instrumentation software right now is not. Parts of it are. I mean, parts of it are written in Node. So it's a scripting language. It's there. You go and look. You've got the source.
There are plans to make that open source as well? No.
It's sounding like a business question.
Yeah, sorry. Well, with technical implications, but.
Yeah, sure, but I can't comment. Are there? Yes.
Question.
Yeah.
Can Max say any more about virtual FBT?
No.
Is there any documentation or more
No,
examples?
No, there's not. I know,
Repeat the
take
question.
a look at the dtrace conference that was held in San Francisco a couple months back.
Yeah.
And look for Brian's talk, because he does mention he mentions something that's needed for VFDT. That just no one's done it. And he wants to take, whoever's asking needs to take a look at that.
I'll share it back. Share. Okay.
All right.
And another one I got. Is there any documentation or more examples on VMRX?
Yes. In the source code, there is a README file. And look in /user/lib/dtrace. Look in that directory and you'll find a bunch of stuff. Okay?
Sorry. Een vraagje. Hoe lang duurt deze?
10 minuten.
Oké, maar het gebouw is dicht op 10 uur.
Hey.
Lights go out.
Yeah.
They lock the doors and we're stuck.
Yeah, we're stuck here till tomorrow morning.
This is okay, we've got an espresso machine.
You can figure out VBFT.
Yeah.
VFDT.
We can do the instant replay.
Okay, other questions?
I don't think so.
What did you say? Also lib dtrace?
User lib dtrace, look there, and look, there's a README in the source code.
Alright. So we'll finish then before we get kicked out of the building, I guess.
Well, thanks for having me, gentlemen.
Thanks very much.
Thank you very much for joining. It was really cool to have you over here. I think this concludes the recording.
I'm stopping it right now.
Okay, thanks everyone.